So while we do have a brief discussion of compatibility, and mutual independence of the actions. So we have been just all of the Newton geometry in Hilbertian construction. We have just classified or reduced them to 5 actions. Actions of choice, action of order, action of connection, and
action of concurrence.
Action of concurrence. And the last one was
Action of connection.
Action of connection. And the last one was what? It was action of completeness. It was not a part of it, but it could be made compatible with the other 5 actions. So the point of the thing is means there is something called compatible and something called independence. So what I want to emphasize is that even though the 5 actions are there, so they form a system, and from that system you can arrive at different theorems, results, conclusions, deductions, statements, propositions. So you can have all sorts of conclusions. The only thing is that they are self-consistent, or they cannot be concluded. So if you have 2 set of those, all the 5 actions, if you take 2 actions, you can have conclusions, and you can have conclusions from any of the 5 actions.
Yes.
And you can come from where you started, or they can be. The question is they can be mutually. There is something called mutually independent. Mutually independence means A, B, C. There is something called consistency. So independence means even though you can arrive at mutually, you can arrive at results from individually or from combination of these, some results which are not contradictory to each other, but independent. They can be independent to each other. For example, you may start from A, you may arrive at E to F, and you may start from B, you may arrive at G, but then you may arrive at F. But the question is, A and B are independent of each other. In no way you can go from B and then you can arrive at A. You have to start at A. So they are, even though from them you can generate mutually consistent things, but somehow they are mutually independent of each other. So their starting points are their own. So you cannot have. So that's the point. That means so this thing is to be seen in our consecutive things. So how we are going to arrive at it? So before we are going to do this, so what we are going to say is that actions. So this is what we are to arrive at this construction that they are mutually independent actions, the 5 systems of actions. Even though they are consistent, but they can be mutually independent. So the independence part of it, which will come later. So in the limited sense, for example, we will try to prove they are compatible. They are system of. They are compatible with each other. Before we are going to jump to
independence.
So before they are consistent with each other. So you can never arrive at a result if you start from any of the 5 actions and construct something. Those deductions cannot be contradictory to each other. So if you arrive at something which is, so it will be shown that it's not possible. It will violate one or the other action. If you any construction which is arrived from these things, it is mutually consistent or mutually compatible with each other. So to prove this point, in the simplest cases, for example, if you consider a domain, let us consider a domain group consisting of all the algebraic numbers between. We construct a domain number rho which would have all sorts of numbers algebraic numbers, beginning with number 1 and applying to finite. So we have a domain number which begins with number 1 and it can be applied to all finite number of domain of operations. Then what we can say is that finite number of arithmetical operations which may be addition, subtraction, division, and multiplication. These are simple operations. If you construct a domain of number root and it starts with number 1, so we can have arithmetic operations like addition.
Addition, subtraction, division, and multiplication.
Actually, there are only 2 operations. Multiplication is repeated addition.
Yes, sir.
Division is also
Repeated subtraction.
So you can just take these 4 operations. And an operation, this. So we can construct this operation where omega represents a number, omega. Basically, you might take as the value number, but it's not saying it, but we can take omega represents a number which is arrived from these 4 operations. Which is arrived from
These 4
so,
operations.
so we are taking these, we are constructing a domain row, and we are constructing number 1, and we are constructing these 4
Operations.
and these operations. These are 4 distinct operations, but this operation we can construct it from these 4
From these
operations as a simplification. Now what we are going to do? We are going to do, so let us regard a pair of numbers x, y, we will take pair of numbers x, y of domain rule as being a defined point and ratio of the key numbers, so we take pair of points x, y of the domain, this domain which we will define. Defining a point, and the ratio of such numbers, is to be where are both not equal to 0. So as defined a straight line. So we define xy domain of this and a number defined a point such that u is to be ratio of these 3 numbers of row where u and b are not equal to 0. We define 3 ratios, ratio of 3 numbers where u and b are not
And zeros.
the third can be
0.
So from this you can arrive at the existence of or not equal to 0. So these things define a straight line. These things define a straight line out. For example, the existence of this equation ux plus by plus w is equal to 0. This condition expresses the condition that the point x, y lies on the straight line. On the straight line, can you see this how it is a straight line where u, v are both not equal to u, v are not both, so this can be an equation of straight line. And the equation of straight line is what? Y is equal to mx
Y is 1mx. You see.
C can be taken as
W.
W. And u and v this ratio of u is to v. They can be numbers. They can be numbers existing on the plane.
Sir,
with
can you
points,
elaborate it? I'm not
x
getting
square.
it. What you
X square. This is another way of saying the same thing in terms of points on a plane which we have constructed from the domain rho and which is subject to these operations.
operations.
So we are constructing a plane, this domain, this in which there is a point x, y, and from x, y, which is constructed in reference to these three numbers,
Numbers.
which are constant, which have interaction with each other. Where the first two are not
Not
zero,
zero and the third can be
third
zero.
can be. The numbers, if we now take into consideration the fact that new numbers, now what we are going to, if we now take into consideration the fact that these numbers will arrange, if x1, y1, so now what we are going to do, if x1, y1, x2, y2, x3, y3 are any points whatever of the straight line, then this will be taken as a sequence of straight line provided by numbers. So if x1, y1, x2, y2, x3, y3 are any points whatever of the straight line, then this will be taken as a sequence of the straight line, provided that the numbers x1, x2, x3 or the numbers y1, y2, y3 either increase or decrease in order. So if you take x1, y1, x2, y2, x3, y2, x3, so we can take where this be constructed as x1, y1, x2, y2 of this domain,
Yes, sir.
where x1, y1, and x2, x3 they may be
Are
constant
consistent.
increasing sequence
in-
or decreasing sequence, whatever, whichever way
Yes.
you are taking.
They are consistent.
So basically we are connecting them with the axiom of connection. And then there is how to find axiom of continuity. In this straight line, construction of arbitrary chosen points. Take this increasing sequence. Then among the series of points, there always exists a certain point you can such that utilize. So you are connecting this construction with our one of the previous actions of
Okay.
yeah, you are taking your action of continuity or arbitrary. So either increase or decrease in the order of the argument. So in that order, action 5 is fulfilled. Action 5 is what I was saying, action of continuity. So from that, you can construct, you can then have a domain which is point constructed of points x and y, and that those individual points will be increasing
Maybe
or
increasing or decreasing.
according to action of continuity. So we have then to assume that all points corresponding to the bracket which make Vx, Vy less than 0 or greater than 0. So all points corresponding values x and y which make Vx, Vy. So all the points, because we are constructing x, y, x1, x2, x3, so on, y1, y2, y3. They are existing in this domain. But this domain is related to these points.
These points.
Which are in constant
Ratio.
with each other. These are certain relation with each other.
Okay.
Their first two points are not necessarily
Zero
others
and can be.
so if we can, these all points can map to this piece in a general sense. In a general sense.
I'm not getting it. In last.
So we may merely assume that all points in the value which make this less than or greater than 0 being less than or greater than 0 shall fall upon one side or the other, upon the one side of the line or the other. So if x1, y1, z1 is this one, or y1, x1, x2, x3, or y1, y, it may be increasing sequence or decreasing sequence. But on that increasing or decreasing sequence, we are constructing a line. Okay. The line segment may be on the right hand side if it's a increasing sequence, or it may be on the
left hand side if it is decreasing.
Decreasing sequence. This is what it is. Okay. So this
Line is defined by these points. Segment. So
upon one side or other of the straight line, which is in the red. This. So we can easily convince ourselves that convention is according to the Schuster Now what we are going to construct, we are going to construct just like we had how we made an angle. It's a parallel how two rays are constructed, how an angle is constructed from a half ray, two half rays.
yes, sir.
So in the same way we are going to make a construction now. Construction is that of construction of an analytical geometry. So a laying of segments angle following by the method. So a transformation will give a transformation x prime is equal to x plus e, y prime is equal to produces a transmission of segments and of angles. Translation of segments or angles. You can take A1, so on and so forth, A4, A5. Then this is A n minus 1. Then this is B. So you can take a point which is existing, a point in B which is existing in B, any other 2 points in B. So a transformation of the form, this you can have transformation, we get x equal to this kind of things. A and B are producing a translation of segments and furthermore, we can have just we have this point, this point, there is point. So what we are going to do, so further we are going to say, further if accompanying the figure, we represent point 0, 0 by 2. We represent point 0, 0 by O and point 1, 0 by E. Point 1, 0 by E. Point 1, 0 by
E.
0, 0 by
Oh.
Then corresponding to the rotation of rotation of COE. CO corresponding to rotation of COE. This is E.
COE.
This is COE. Corresponding to rotation of COE xy, any point xy is transformed into point
X prime, Y prime,
transformed into x prime,
Y prime.
y prime. Go to point.
Yes, sir.
Are so related, not it's the point of how we can relate a given point xy, which is rotated
Rotated
like
like
this.
Yes, sir. Yes.
How they relate this point to
This way.
this point. So we can we write x prime as a by root of b square plus
A by root of A square plus B square X. How, sir?
minus d by root of b square plus b square into so x prime can be basically this is xy, this is xy now. So you can take x prime as a difference of x prime as this is a. So we define x in terms of a and b. X in terms of a and b. So x is a difference of this minus this. This minus this. So if you just so x is if it's like this. So this minus this x prime will be equal to
Should we continue it on tomorrow as times of our colors?
it can be transformed into this. So and y prime is equal to b by root of b square plus b square into x plus a by root of b square plus b square into y. So y is basically a square plus b square is what? This is a and this is a and b. So this is a is x.
It should be a hypotenuse of the triangle
Oh.
by Pythagoras theorem. If it is right
This
angle,
is a square plus b square plus.
B square.
This is
This is B.
perpendicular over hypotenuse.
Yes, sir.
And
B
this.
into X.
So y prime can be written as this. This plus this y prime can be written as this plus this point. Just wait one word. Y prime can be written as this is this. This times this plus a by root of and this is b. So it is basically how points x prime and y prime. How we can have x and y. They are translated into x
X
prime
prime,
and
Y prime.
x prime and y prime. Can x be written as x plus something? X prime can be written as x
Plus
plus this and y prime. X prime can be written as x minus this and y prime can be written as
X plus Y.
x plus this one. This is x prime can be written as x x minus this and y prime can be written as this. So this is what it is. So just if you have confusion here. So you can say, so can we write when we have just when we have a certain different set of rotation or the point x, y, x prime, y prime. So they can be related. They can be related via this construction. Now the point is this x prime is written in terms of x and y. This y prime is also written in terms of x and y. Mod of these points A and B. So this is the point. Since the number, so we just do it. So it's not entirely clear, but it is. Since A square plus B square can also be written as this 1 plus B by B square. Belongs to the domain. Belongs to the domain. What is under the conventions which we have made, the actions of congruence. So you are saying that we make these things. The actions of congruence hold. Actions of congruence hold. What is the action of congruence? Action of congruence, if you remember.
SAS one.
If two actions lines are
Two sides of the line are congruent.
or if two segments are congruent with the segment, they are congruent
each other.
So from this, how does it follow that if two segments, if you make a construction where we can rotate this point, any point, and rotate x1 point is rotated by some this angle. From this construction, you can have. So it will belong to action of congruence. This is what you are going to see.
We should continue.
The same is true for action of arguments. The other action of division of action of arguments is action of continuity. The same is true for action of continuity. That if A1 action of continuity is what? That A1 will be the point on the straight line between arbitrary chosen points A and B. So again, basically, now I got. So basically, this x prime is basically addition of this plus this. This point x prime is taken as it is constructed, x prime is constructed of the points x and y. When x prime is constructed of the points x and y prime is constructed of the points y. So if you make arbitrary constructions x prime in terms of x, we are writing x prime in terms of x and y prime in terms of y. Yeah, just wait. What is can we write this way? This is the mean. Can we write from this diagram? Can we write in terms of these two constructions satisfying the axiom of
Continuity.
Continuity axiom of
Congruence.
congruence from that. Can we write this way? Can we write this way? That's the point. It's not.
Should we conclude here, sir? As
we will conclude it next.
so continuity on tomorrow as it is on in class mathematics.
So we just the next class will make this point more clear.
Yes, sir.
So you can also think of it. You just take this figure.
Yes, sir.
And correspond to this figure, he has made these two things. So whether this is allowed by the action of continuity and action of congruence, or can we make rotation at this point x, y, so is it allowed by this? So you think over it. So next class we are going to start from this and basically we are going to prove the independence of action of parallels in non-linear. Starting from this.
Yes,
So
sir.
prove the independence, which I was saying. This was not independence, it was compatibility. So they are compatible.
Okay.
For example, this thing is allowed by action of continuity and action of
Congruency.
So this operation is allowed by that. So this is what we are. Next one we will show that the action are independent. Start from the start.